Are you okay? I really hope so. Today we are going to talk about the Newton's law of cooling. We are going to make some math and we're gonna code. Okay? And we're gonna use this law make a count with the coffee. Okay? How many times till it freeze it's cooling right like 10 times. I mean 10 minutes. So what we need to know it's the count. We need to make the quantity express it like the final temperature. It's equal the ambient temperature more plus the initial temperature minus the ambient temperature. Okay, it's multiplying the Euler. It's multiplying the Euler to the minus key times to the time. That's the count. Okay, let's put it up. Okay, now what we need to isolate it's the k, okay, because it's in this equation. It's gonna be the constant value, okay, and we're gonna isolate the constant value, okay, the key. And so what is the first temper, the ambient temper, the initial temper? Let's talk about the coffee, okay? We are going to make a coffee. I'm using the temperature in the Celsius, okay? So the final temper, let's say the final temper, it's what's the temperature it's got for let's use the time like 10 minutes. The initial temperature, it's when you are boiling it, okay, when you are boiling the water to make the coffee, and let's say it's the 100 Celsius, and the final temperature it's the 40 Celsius, and we're gonna take this 40 Celsius after 10 minutes in the ambient temperature, which it represent the 25 Celsius. Okay, so with that values we can make the count. So let's go to isolate the key. What we're gonna do, the final time minus the ambient time, it's equal initial temperature minus ambient temperature plus the Euler, so the minus k times time. Let's isolate this expression passing through there, so it's gonna be divided by the initial temperature minus ambient temperature. Now I can put it like that. Okay, now we're gonna to use the logarithm to take it the log of the first temperature minus ambient temperature divided by initial temperature minus ambient temperature. It's equal the minus k times to the time multiplying the log to the Euler. So we can put this expression dividing there. So it's gonna be divided by that expression. There is the count. Okay, that's what we need to know to make the algorithm decay its isolate. We just need to pass the minus signal to another side, so here, and it's done. The key value is isolate. So how it's gonna be if I use the numbers? It's gonna be the log of the first temperature, it's 40, minus ambient temperature, it's 25, divided by initial temperature, it's 100, minus 25, divided by the time. We know it dropped 100 for the 40 Celsius in 10 minutes. So in 10 minutes to the log of the Euler, it's gonna be the key. We know the Euler is approximately 2.7. Let's make the count with the calculator. But first, here it's 15, and here it's 75. Okay, we can make divided by 5. It's equal 3 and 15. Okay, so it's gonna be the log 3 divided by 15 divided by 10 times log the Euler. It's the minus here, it's the key value. Ten divided by 15, it's 0.2. The log, it's the minus 0.69 minus 0.69, and the Euler log multiplying to 10, it's 434. It's 434. Now we divided the minus here, we are making plus because of that signal. Then it's 69 divided by 424. It's 0.15. 0.15. It's the key value. I'm just passing the math so you know what's going on now. We're gonna make this count with the Python, okay? And make a graphical with the Matplotlib to take a look how many time we can wait to drink our coffee, okay? So we're gonna use the NumPy as NP, it's the nickname, and let's go, and then the initial temperature, it's 100, the ambient temperature, it's the 25, and the final temperature, it's, let's say in 10 minutes it's dropped to 18. I think it's more realistic, okay? It's gonna drop 20 Celsius in 10 minutes. We can use the time 10 minutes. That's up to you to take a look what's the temperature after the 10 times. Then you create your equation here like I'm doing with you. So the key value, it's gonna be the minus, let's use the NP, the log of the 10. Now we're gonna pass the final time minus the ambient time temperature, divided by the initial temperature minus the ambient temperature, and everything is divided by the time multiplying the log, the 10, the Euler. Let's take a look, the key value. Oh, 10. There is it, 0.03. If we use the already like we did before, it's gonna be give us the 16. We have got on the math the 15, but we got the number, we got the rounded to the nearest multiplier of the 15, okay? But in that case it's literally 1.16, the constant value. Let's keep it the final temperature like the 18 in 10 minutes. We don't need it anymore. We already have the key value. So let's make the graph with the matplotlib. With the pyplot as plt. Okay, we're gonna create a list to insert, to append the values so we can drop it on the graphical in using the range, like the ranging 10 times. We're gonna use it 10 times in 10 times. It's gonna be such as 100 minutes time, and the temperature, the list for I in range. We're gonna make a loopy in 10 times what I said, like I said. So we're gonna pass the times. Let's see. Let's express it in times. It's like the I multiplying the t. And now we pass the equation again. We're gonna pass the variable we don't know, it's the final temperature, okay, because we are going to pass in the range. So let's say it's the final temperature, like that. It's the ambient temperature plus the initial temperature minus the ambient temperature. It's multiplying the Euler to the minus k times time. Okay, NP Euler minus k multiplying the time. In that case, it's the times, because we are multiplying the up to the 10 ever looping. Now we get the time, append times, and the temp, append the final temp, append. Now we're gonna use the matplotlib to create the graphical. It's the, let's create the figure, the fig size. Fig size. Let's make it 6 to 6. It's like a square with the 6, the size. PLT plot. Now we're gonna pass the value in the y and the x. Okay, it's the times and the temperature. The maker, let's create the O to maker, the color, let's use the red, and the label coffee temperature, PLT, the title, coffee cooling times let's use let's pass the values in the X label. The legend, let's say it's the X label, it's the time in minutes, and the Y label, it's the temperature in Celsius. Okay, and we gonna use the line on the background, it's the grid. Okay, PLT grid, let's say it's true. PLT the legend, and PLT show. Let's run it. It's an error. What's going on? What is going on? Marker. Shit. Marker. And the list is, it's called time. Here is it, there is it. It's jumping in 20, so let's use it in the time. Let's use something more efficient to take a look to the code. Let's use the Xtrix NP range. Started with the number 0, ends up with the 101, and jump it 10 times. Now we have it 10 times, and with 10 minutes the temperature of the coffee, it's 80 Celsius. In 10 minutes it's dropped, so we can see in the 20 minutes it's dropped to the 75, and so on. Like here in 50 minutes the temperature will be dropped to 40 Celsius. Okay, and with 90 minutes it will be almost the temperature time, the 25 Celsius. So there is it. I hope you have enjoyed. That's for now.